Hello friends, welcome to my channel. In this video, I am going to discuss about electrostatic potential energy at a point. Okay, so I am going to consider as a capital Q charge, and here there is a point P. At this point, I need to find out electrostatic potential energy. Okay, so we already know electrostatic potential energy difference between 2 points. Delta is equal to work done to move a charge from one point to another point, or initial point to final point. Okay, so this delta, what is delta U? Potential energy of the final position, that is UF minus UI, that is equal to work done to move a charge from one point to another point. This we already studied in the previous video. Those who are not to be seen the previous video, please see that, then come to this video. Okay, then it is more, then this topic is more, you can understand very easily. Okay, clear. Okay, so electrostatic potential energy difference between 2 points is the work done to move a charge from one point to another point. Okay, so here what I am going to do means, I am going to consider the initial point. This initial point I am going to consider as infinity. Then what is the work done I am going to find out. Okay, so this is my point of infinity. Clear? So here what are the forces? Here there is my Q charge. These charges I am going to bring from infinity to this point. Okay, so here what is the force is acting between them? Here in this path I am going to bring. Here what is the force is acting? This plus Q charge is producing an electric field. So this plus Q charge will be produced as a electrostatic force. Is in which direction? In this direction. This is the electric force. Okay, I want to bring this Q charge from infinity to here. I have to apply an external force. In which direction I have to apply an external force? In this direction. This direction is the external force. Okay, next I am going to find out what is the work done to bring a Q charge from infinity to this point. Okay, so this charge is bringing, this Q charge is bringing from infinity to this point. So work done to bring Q charge from infinity to P. Work done we have to be represented like this, infinity to P. Okay, that is equal to what? We already know. Work done to bring a charge from initial to final position is potential energy of the final position minus potential energy of the initial position. Here the final position is potential energy of P minus potential energy of the initial position, that is infinity. What is the potential energy at infinity? The potential energy of the infinity is 0. Why? Because there is no electric field is at the infinity. So work done to move a charge from infinity to P point is how much? That is equal to potential energy at the P point. Okay, so we can define the electrostatic potential. Here we are doing a work against the electrostatic field. So we can define the electrostatic potential energy. Okay, so electrostatic potential energy at a point due to a charge is the amount of amount of work done to bring that charge from infinity to that point. This is the definition for electrostatic potential energy at a point. Electrostatic potential energy at a point due to a charge. It is depend upon the charge value. Okay, so what is the value of this work done? Work done to bring a charge from infinity to P point is, we already know, minus of integration of infinity to P. In the previous topic we are already knows F electric field into the displacement. That is, here we can get what? Fe into dr. What is this Fe? If Fe we knows that what? QE. This is the force experienced by a charged particle in the electric field. E is the electric field produced by which charge? E is the electric field produced by this capital Q charge. Force is experienced on which charge? The bringing charge. Okay. So here we can get the equation is, how much is that? Work done to move a charge from infinity to P is equal to minus of infinity to P QE dr. Okay. So this is equal to how much? This Q is a constant. It is not depend upon the dr. So we'll take it as a minus Q into integration of P infinity to P E dr. That is the work done to move a charge from infinity to. What is this work done? This work done is equal to what? Electrostatic potential energy at that point. So electrostatic potential energy is equal to what? Equal to minus Q into infinity to P E dot dr. That is, it is depend upon the charge Q. Clear? It is depend upon this value is depend upon the charge. Here, if we will bring Q1 charge, what happened? This formula is become Q1 into integration of E dot dr. Okay, so that's why in the definition it is like this: electrostatic potential energy at a point due to a charge. It is the amount of work done bring to that charge. So this quantity is depend upon what charge we are bringing. So that is about a electrostatic potential energy. Okay.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like